So yes, today we'll cover tidyr, two packages, tidyr and dplyr, okay? And these are both created by Hadley Wickham, who is this amazing programmer for R, has really advanced the R language by creating some incredibly useful packages, and these are among the most useful packages for handling data in R. So tidyr and dplyr, okay, and we'll talk about these. Okay, so again, you can copy this link down, and this will pull up the same slides that I have up on the screen, and also under the RStudio website, there are these cheat sheets that exist, okay, and they're kind of like summaries of the commands that we use in dplyr and tidyr. There's also a cheat sheet for R Markdown, just some different cheat sheets that are very useful for the RStudio packages here, okay? Okay, so we've talked about data frames, okay? And so data frame is basically a two-dimensional data structure where each row is an observation and each column is a variable. And the way it's stored in R is it's a bunch of lists, right? Or it's not just a bunch of lists. I'm sorry. It's a list where basically each element in the list is a different column, but all of the items in that list have to be of the same lengths to make it a two-dimensional structure. Okay. Now, I don't know if you guys have experienced this in R, but if you simply ask something like if you just type in a data set such as empty cars, okay, it tries to, R's default setting is to try to, and actually it's not that big of a deal here, it's going to try to print the entire data frame into the console window, okay? Now if you feed the same data frame into the table, or tibble, I should say. Oops. Let me see. Is it as, do I do as.tibble? I'm sorry. Okay. If you feed it into what we call a tibble, a TBL, what it does is it only outputs a few of the rows. And if you had like a ton of columns, it will only output what fits in your screen, okay? And so there's something called tibble, and actually if you ask R, what the class of object that a tibble is, it will say it's a tibble and then a data frame. So a tibble is just this thing that wraps around what a data frame is to just make it a little bit friendlier when when its output is shown on the screen. Okay, so it just basically cuts off and shows only the variables that will fit and only the rows that will fit. Okay, so extra variables will show up here as variables not shown, and it will actually also tell you the way these variables are stored. So this will say these are all stored as doubles right here. Okay, and so this is what we have. Okay, and then you're probably familiar with the command view, where if you have something loaded into this thing, if you click it, the default command is to run view, and it will appear up here in almost like a little spreadsheet in Excel. So you can do and with a capital V view empty cars or something, motor trend cars, and it appears here as a kind of little data frame here. Okay. One thing you'll notice is that the tibble does not display the row names. Okay, we generally don't. We often don't use row names. Okay, and so when we use the tibble, the row names disappear. Okay, whereas when you the default data frame preserves the row name, which is, I guess, useful if row names have been used in the display of the data. But you can kind of see that over here we actually don't have a variable name here, but what we've done is we've used row names here rather than just the row numbers. Okay. All right, and then we've got the pipe operator, okay, and we'll talk about this. Okay, so actually, if you guys are, I know, okay, so I'm looking around and I see a lot of you guys have your laptops. So if you haven't done so already, go ahead and just type in install.packages, okay, parentheses dplyr. Okay, now I've already run these. I already have these installed on my machine. So if you want to follow along, run install.packages dplyr and install.packages tidyr. Okay. So I'll do that right here. Install.packages tidyr install.packages dplyr. Okay, because these are the packages that we'll be covering today. All right, so get those loaded up. Okay, and then after you have those installed, do library tidyr and library dplyr. Okay, to get those loaded, and then we can start using these things. Okay. All right, just let me know if you're having trouble getting these installed. But I'm gonna just continue on here. I mean, in lecture you don't have to follow along on your keyboard, computers, but if you want to, I just want to make sure that you're going to need these things installed before we can go on. Okay. So a lot of times in R, we are. So let's see. Where's the diamonds data set? I forget. Okay, all right. Okay, so I'm going to load the diamonds data set, which is going to be part of ggplot2, okay? And you know what? Okay, install another package, which is NYC Flights, NYC Flights 13, okay? This is a database of New York City flights, okay? And do library NYC Flights 13. Because we'll be taking a look at that in a moment here. Okay, so load these up, and then you know, we can just take a look at kind of like the diamonds data set, and we can see, you know, there's 53,000 entries, 9 columns. If you ask diamonds, it shows up as a tibble, okay, which again only contains only displays 10 rows and the variable types there, okay? And so, you know, we might be accustomed to doing things like mean diamonds $sign depth, okay? Something like this. And that works. To take the mean of this column depth here. All right, and then one thing we can do, however, is we can use this pipe operator. Okay, this pipe operator, and what it's going to do is we just you do diamonds, the pipe operator. Okay, oh, I'm sorry. Diamonds dollar. We'll do it this way. Diamonds $ depth, and then I just pipe it into mean. Okay, and it does the same thing. Now this doesn't seem any more efficient. Okay, at this moment in time, but what we'll see is that a lot of times in R we will nest one function inside another function inside another function inside another function. Okay, and if I don't know if you guys have experienced this, but sometimes, as you have functions nested inside of each other, it can get rather complicated, okay? And so what the pipe operator does is it just kind of creates almost like a little path that says basically take this function, its output, and pipe that output into the next function. And then take the output of that function and pipe it into the next function, which is effectively the same thing, because when you have functions nested inside of each other, basically what R does is it evaluates the innermost function. Once it creates that, then it evaluates the next function outside of it. Once it evaluates that, it evaluates the next function outside of it. So it's doing the exact same thing, but what it changes is it makes it more readable for us as humans, because I think as humans we have generally a linear flow in terms of reading things, and so the pipe operator would do something like that. So instead of something like, I don't know, like let's say you wanted, you have some kind of data, and you want to do some kind of like subsetting on the data. And then after you do the subsetting, you do like a further subset, okay? And then, you've got to do something like this, and then you want to take the, sort it, and then you take the, I don't know, the mean or whatever. So you do something like that. You've got something like this. And instead of writing something like that, what you would write is you'd write data, and then you'd pipe it, and then there's like a nice little keyboard shortcut. If you're PC, it's Control-Shift-M. And if it's Mac, you do Command-Shift-M, and then so here you would just pipe it from the data to the subset, and then subset it further, and then you would sort it. And then so here it's kind of a clear linear path of you're going to do this, then you're going to do this, then you're going to do this, and then you're going to do this, rather than trying to decode exactly what's happening here. Okay, functionally they're the same, but in terms of readability, I believe the pipe operators make it easier to read. Okay. Yes.
Just a quick question, because my R basically said that PDR and MIC5 was built under R version 3.5.
So that means you have an outdated version of R installed on your computer, and it'll probably work fine, but if you run into problems, you probably want to update your version of R. Okay? Okay. So, all right, then it talks about data wrangling, and then, we might call this munging or janitor work or manipulation or chance, and then it says, this is, yeah, whatever, okay. Basically, we do spend a lot of time just trying to manipulate data into something that we can use, okay? And it says, we got two goals. We want to make sure the data is suitable and that it reveals information, okay? And it says data sets come in many formats, but R prefers just one. And the format that R prefers is basically the data frame or the tibble, where we've got one row for every observation and one column for every variable. Okay. All right. So here are the data sets are contained in this this thing called EDAWR. All right. I don't know, something data wrangling, okay? And so to get these loaded into R, we can run exactly these commands here. Install.packages. If you haven't already installed them, DevTools. And then we're going to install some files from GitHub, okay? What's going on here? Okay, and then we're going to do DevTools, whoops, DevTools : what the : means is that I don't want to load this DevTools library at the moment, but within that DevTools library, just use this command, which is install_github, okay? Install_github and EDAWR. I'm sorry, RStudio/EDAWR. And then we're going to just open a few of the data sets that come loaded in EDAWR. Okay, and so we have this, and then we can ask about pollution and things like that, and it's just pollution data, right? Or whatever it is we're looking at. Okay, so if I type in, we're going to look up at this data set pollution. We're going to look at this data set storms. Okay, we're going to look at the data set cases. Okay. All right, so these are 3 different data sets, and this is just how different things are stored. But what we want to do is we want to turn it into a form that R can handle. All right, is everybody's computers working okay? If you're following along, we're good so far. Okay. All right, and so these are the data sets, and we're going to take a look at each of these to just kind of see how we can manipulate these data files into something that R wants, okay? So the storms is in the form that we like, okay? You've got each column, storm name, wind speed, and date, or air pressure. These are all one column, and each row is an observation. So storms is in a form that we like, okay? But if we look at cases, okay, how many variables do we have? We only have 2. It's country and year, okay? Those are really the only 2 variables that we have, and then we have a count data stored here, okay? So this is a little bit in a different form, okay? And then what we have here for pollution, okay, we have city, okay, and then if we look, we can break it up into two additional variables. We have 3 variables where we got large particles and small particles, and maybe we want a column for large particles and a column for small particles with the values in there, okay, and so we've got kind of the data set formed in this slightly odd form here, okay? And so if we have data in these forms and we want to get it in kind of this form where we've got one column for each one, we can use tidyr to help clean us up, okay? So when we have it in storms, you can reference each each variable by doing storms, $storm, or $wind, $pressure, $date, and this is nice for us, okay? But if we want to get like the variable for large particles or small particles, we would have to subset it and say, like, basically, let's look at the odd rows or the even rows or something like that. Or with the cases, you know, trying to get the values in here, you have to perform some little bit of R acrobatics here, okay? All right, and so, you know, we like to have it in this form, storms, $storm, and wind, because let's say we want to create something called a new column called pressure, right? Which is going to be, I'm sorry, a ratio, which is going to be the pressure divided by wind, okay? We can do that when they're in this form because we can just do, you know, storms, $pressure divided by storms, $wind, okay? And basically, because R handles everything in vector form, it's going to just do element-wise division, and it produces the values that we want here, okay? Okay, yeah. So the tidy data, this is basically what we have. Each variable is its own column, each observation is its own row, all right? So that's what we like. Okay, so how can we use tidyr to gather, to change the other data forms into the stuff we have, okay? So again, if you haven't loaded tidyr, go ahead and do that. And the two functions that we're going to primarily use are gather, okay? And you can look up how gather works. It takes the data and then a key and a value. These are the key parts of gathering, and then we're going to later on use the command spread, okay? So what we're going to do is we're going to take this data, and it says, you know, how would this look if we created it as a tidyr data frame, okay? We would have three variables: country, year, and number of cases, n. Okay, and so if we were to do this, this is what it would, we would have three columns: country, year, and cases, and then we would do France 2011 has 7,000, Germany 2011 had 5,800, and the US in 2011 had 15,000, okay? And we would, so our final data set would look something like this, okay? Is this okay? Going from this table into this form here. Good with everybody? Okay? And so, you know, from this form, we now have each column, its variable here, okay? And so to go from here to here, we're going to use the command gather, okay? And all of the data is stored in here, and so what we're going to do is we're going to, if we look at the command gather, it takes the data and it needs something called a key, and it's going to need something called a value, okay? And so the key is what we're going to use as the key will be the column names, okay? And then the values will be what's stored in those columns, okay? And that's going to be n, all right? And so the way we write this command is we're going to say gather the data in cases. The key is the year, okay? And we're going to run the value n for the and we're going to run it on the columns second through fourth columns, okay? So again, breaking it down, this is the data frame that we're going to reshape. The name of the key column, which is we're calling this year, but it's going to be the column names, okay? And then and the name of the new column, which is n, and the we're looking at the second through fourth columns, okay? And so basically, all this is we're just giving it a name, okay? We're just calling it year and we're calling it n. We're just giving it names. These are just names. It doesn't, these of themselves don't have specific meaning, but gather is automatically going to do this when we tell it to look at the second through fourth columns in cases, okay? So we can do this. We can do gather, and we're going to say take the data in cases, and then we just have to give it some names. We can call it year, we can call it anything else, okay? These are just arbitrary names. In our case, it makes sense. And we're going to say just look at the second through fourth columns, and it's automatically going to figure out what it should put in those things by looking at the column headings for columns 2 through 4. Okay? And then it's called those headings year and end. Okay, and so there we have it. Did that work for you guys? Okay, and so this is very useful because sometimes you'll see data stored in this form and you want to turn it into something like this. Okay, and then once all right, and so if I look at cases underscore tidy, I got this, and then now I can subset it just like the way we have earlier. Okay. All right. So that's gather, and then we have, let's say we have data stored like this, okay, where we want to turn this into a tidy data set with 3 variables: city, large particles, and small particles. Okay. And so this is going to be large and small, and then we're going to have New York has 23 and 14 small, London has 22 large, 16 small, and Beijing has 121 large and 56 small. Okay, so this is how a tidy data set would look in this case. And so to go from something like this, we're going to use the command spread. Okay, the parts that spread uses, if we look up the help on spread. Okay, again, it takes the data and then it's going to take a name for key and value. Okay, and so we'll take a look here. Okay, so spread, we want we're going to take the data set pollution. We're going to use the column to use for the keys, and then the column to use for the values. Okay. So again, we've got size and we have amount, and what it's going to do is it's going to try to look. It's going to look at the column size here, and try to figure out how it should figure out how to spread the data here. Okay. So if I do spread pollution, here. Let me just take a look at pollution. And we're going to take the size column and the amount. Okay, and so because we are not naming new columns here, okay, it's going to create the column names itself. We have to just put in size and amount. Okay, whereas when we did gather, we were making up names ourselves and we could call it whatever we want. With spread, we have to tell it, look at the size column, look at the amount column. Okay, because if I had a typo here, it'll complain and say, we don't have this. Okay, whereas when I did gather, I could call this whatever I wanted. Okay, and it would work, because here we are creating columns, and over here we are taking the columns in pollution, and it's going to look at this column that says the size of the particle and match this up. Now if there's a typo in this thing, like it says large, small, and large, and then the last one had a typo and it was like smalled or something like that, smalls, then it would create a third column for smalls. So let me so here's pollution, and I'm going to just create pollution typo, and this is going to be pollution, and with pollution, whoops, typo, what do we want? We want the 6th row and the second column, I'm going to use smalls, okay? So if I, so here I've got pollution, and then there's a typo with smalls. If I try to use spread on pollution typo, okay, here you can see what happens. It says it recognizes large and small, and it matches up those things. But then because of the typo here with smalls, it puts it in it thinks that's like its own new column, and now we have missing values here. There's a question.
What was the shortcut you used to call previous?
Oh, previous functions? Oh, the up arrow. Up arrow on your keyboard will run through your history of things you've typed into R. Okay. Is what's happening here okay with spread? Okay. And so there is kind of this relationship between spread and gather. So if you have data kind of like this, you can spread them this way. And if you have data in this form, which is what that cases table was, and you didn't like that, you can gather them, and it will assign them this way. Okay. And when you gather them, it takes the command, it takes the column headings, large and small, and it puts them into one column here. Is all this okay? Unite and separate it. Okay, well, all right. It says there are 3 more variables hidden in Storm's year, month, and day under date. Okay, and then we can chop them up using the commands unite and separate. All right, and so this is a little bit more tricky. You know, if you really want to do this, you can do this. I have a hard time, you know, I have a hard time imagining when you would want to do something like this if you don't have date data. Okay, so maybe you have like computer output, and then for whatever reason the part of the output is like a lot of things encoded into like one funny text thing, right? It could be like the way you name files could be something like I don't know, like data underscore June underscore Tom's something report or something like that. Okay, and you might have some weird way to do this. Okay, because this function, by chopping up the date into year, month, day, this is useful, and this is a legitimate use for this command separate, but it's in my opinion it's easier handled by function. There are built-in libraries called lubridate. It's like a play on the words lubricate, but used for date data, and it's like way easier. Okay, so if you look up lubridate, it like recognizes when you have date data, and then it can extract day, month, all of that stuff very quickly. So yeah, this is a legitimate use. You can look at this, and then if you have something like, and if you want to work things in the opposite fashion, where you kind of concatenate them together into this, that's also fine. Okay, but I'm not even going to bother with this stuff. Okay, so tidyr, it makes your reshapes your data there. Okay. Any questions about this? All right, so I think tidyr is an incredibly useful package. A lot of times you do get data that is in this odd form, or just not an odd form, but just a form that doesn't play as nicely with R, and tidyr will allow you to quickly reshape that data. Okay. Okay, I'm going to